Hi guys, welcome to another Learning Electronics Repair video. I have a graphics card here, sent in by a subscriber. He says please find and enclose the graphics card, tells me where it was bought from, he had it for 2 years. This is the pre-overclocked card. One day it developed a fault and was not recognised by Windows 11, giving an error code of 43. The card works, but in a low resolution mode only. I'd be grateful if you can try to fix it and let me know. Okay, so that's what we have. The graphics card's the card itself is actually a Radeon card. This is the dual RX580, 8GB. So this is the actual card we have. It looks to be in reasonable condition. Don't see any obvious problems on this side of the board. So I think what we'll do is we'll just take the card apart and then we can have a look to see the other side of the board and all the usual things. Visual inspection, resistance checks, voltage checks, and then plug it in. I'm assuming because of what the owner is saying that all the resistances will check okay, it will actually power up, but as he says, with this error 43. So let's have a look. Some people like to just use pliers to remove these things with a warranty thing on. Yeah. I mean, I'm assuming this card is not in warranty, which is why it's been sent to me, so I'm not too bothered about that, but I will just, unless you have not particularly seen it, how to do it, and be careful not to knock off any close by capacitors or whatever, yeah. So you can actually get these things off. But now, having shown you how you can do that, I'm just going to use a screwdriver, as I'm not in any instructions to preserve the warranty seal. There may be another one somewhere anyway when you try and open it up. So we'll get this apart. Let's see, yeah, it comes apart quite easily. Remove the fan connector, and there we have it. So that is really quite dry. In fact, it's very dry. Makes me think maybe this has some sort of problem with the GPU, possibly, because it's, you know, will have been running quite warm. It doesn't have any sort of heatsink pads on the RAM on this board. Let's have a look around then under the microscope and let's see if we can see anything obvious with this. Here we are. So there really shouldn't be any broken off components on this side, especially as we had the seal still on there. Nobody should have been messing in here, unless they used pliers, of course, to take the screw out. But I'm not really expecting to find any visibly broken components. We might find something that's burnt. We can have a look. Okay, just adjust the focus slightly. There. There's not that many components on this side of the board really, it's not heavily populated. This is the VRM section. Not a lot to see there. Let's move on, folks. This lot's underneath the heatsink, so I ought to take the heatsink off to have a look to see if there's any visible problems there. Just there we go, focus. And these are the drivers, the MOSFET drivers. So that basically looks okay. Let's get this heatsink off. We can now see the MOSFETs. Looks like we have, yeah, it looks like we very much have one high side, two low side on each phase. We have 6 phases here. And they're probably the V core, because we have on the other side, over here, probably the one for the RAM and another one there probably for the memory controller, and we have some more. So there's going to be PEX and such like 1.8 volts maybe. So that all looks okay. Let's have a quick look along here. All the fingers look nice and clean, but the capacitors are on the other side, so let's flick it over and have a look. Again, I've altered the height a little bit, so I have to just alter the focus. Let's see what we have. Mainly empty space down here. No obvious problems. Well, that looks pretty good. Just down here. Nothing broken off that I can spot. This is behind the GPU. And these are the capacitors down by the PCIe. So just check all those are present. Yes, there they are. Again, just adjust the focus a little bit. There's not so much on this side really. Okay. And that's basically it. So it all looks okay. Let's have a quick look on the ohm meter. As usual, 12 volts and 5 volts coming in. Yes, a few kilo ohms, that's fine. 1, 2, 3, 4. That's the 3.3. It's fine. 12 volts coming in over here. It's fine. That'll probably be on this coil. Looks fine. This one. Yep, looks fine. This would be the V core, which is going to be quite low, 1.3 ohms. This will be on all of the phases the same. That's probably quite correct for one of these GPUs. I have one here. 25 ohms, could be the PEX supply, I mean, it's down here, so it could be the PEX 0.9 volts. That's in the kilo ohms. That's probably connected to the 12 volts here actually coming in. Yeah. Another one here. 25 ohms, similar to that one. Wouldn't be surprised if it was a memory controller. This one I expect to be the RAM. Yeah, 33 ohms is Samsung. No, but it's 33 ohms. Doesn't seem too far out of the way. Samsung you'd expect to be like that. This one, yeah, kilo ohms, that's okay. This one, kilo ohms, that's okay. So the only thing I can really suggest is maybe the RAM reads a little bit low at 33 ohms. I'm not sure if I have another one of these to compare with. Have a quick look. I do have another one here. This may have 40 RAM actually. PEX 26.7. If it is PEX 25.9, basically the same. This one, these two coils we have to go underneath to get at them. The V core is about the same, so 1 ohm, 1.1 ohm pretty much. These two coils, which will be the equivalent of these two power supplies on this, we have to flick it over. So let's have a look. So we have 27.9 and we have 18.2, and ours has 24.9 and 33. So if that is the RAM phase, then this is also the RAM phase. The RAM reads low on this, but I say it may have 40 RAM anyway. this is a different type of chip. So we can compare, but only get so much information from the comparison. Let's just check the resistance on the PCIe itself. On the PCIe, we'll just use diode mode. And we'll look at the first few lanes. So we have 3 and 4 in on this side, third one, fourth one, 0.76, 0.76. Let's look on the other side. So they both basically read the same. I'll just make sure they're not shorted to each other. No, they're not shorted to each other. They shouldn't be shorted to each other either. Let's look at these. So we have second and third one. That reads okay, and it should read the same as the third one. Yeah, and they shouldn't be shorted to each other. Okay, and then the last one we'll read is the other part of PCIe lane 0. So we can find it. Well, this should read open because we have the capacitors here. So to check these, we have to read from the other side of the capacitor. But they should basically read all the same. That's a bit low, actually. 250. Maybe they just read quite low on these cards, yeah. On just the other side of all the little capacitors. Whatever they read, they should all read the same. We can say that much. This reads lower than some other cards I've seen, but it doesn't necessarily mean there's a problem there. I think what we can say, they all read the same. And if I look on that other board, I should basically see the same reading because it's the same type of GPU. So I can just have a quick look on the other side as well. These are the more likely to have any damage because there's no capacitors to protect them. They will normally read different from the other side anyway. This is more typical to the reading I would expect to find. Okay, I can see where the tracks come down from the GPU actually. Yeah, you see them all coming down here. So I'm just basically going on the pins where the tracks go to basically. And I'm expecting them all to read the same. The only thing I can say is the readings on the other side are slightly lower than I expected, so I will just check on the other card. Let's see how this one reads on the side with the capacitors. About 2.25 was what the other one said. Yeah, so it's basically reading the same, so that tells us that is actually okay. Let's go ahead and power this up then and just check the voltages. We'll know which one is which then, and if they look okay then we'll try it. But as I mentioned, from what the customer was saying, the voltages will probably read okay. Let's see what we have. So first one we'll go for is VCore. So if this is here, all the others should be here. Power it up and we have VCore 0.9. This is probably 12. We have 12. This is another one, probably 12. 12. Then we have the ones on the other side. 5 volt regulator. This is the RAM. Yeah, 1.5, that's RAM. So this is probably the memory controller, 0.859, which is going to be very similar to the VCore. Then this will almost certainly be the PEX, 0.9 of a volt. Yeah, that's good. This probably 12 volts. And then this might be 1.8. No, that's 12. Okay, so if there is a 1.8, it's, well, wherever it is, yeah. 12. That's all of the voltage rails. So everything seems to be there. Every single one has actually has a voltage on it, so that's a good sign. There probably is a 1.8 volt regulator, but it'll be like a little 8-pin chip or something, which is effectively just a series voltage regulator, an LDO, because there isn't much power being drawn from the 1.8 volt supply. So all the voltages are there. So the next thing then is to put this back together, put it in our PC and see what it does. I'll add some fresh heatsink compound on this. Okay, maybe a bit too much there, we'll see. And then let's get it put back together. I've attached my HDMI cable to the graphics card. The owner was obviously using a display port, but I don't have a monitor at the workshop with a display port connector on it. We'll put the power on. Let's see if we can get a BIOS screen. I don't have the hard drive attached at the moment. So it's powering up. We get one bleep out of it. I'll put my monitor onto HDMI. Do we get a picture out of it? The fans have stopped again. Yes, okay, so it's actually asking me to insert the boot device. So it does at least work to that extent. Okay. Which ties in with what the owner said, of course. Let's put the hard drive on and let's try to get into Windows with this. Well, I have Windows loaded, but much like the owner said, if I get a focus onto it, make the screen a bit bigger, you will see we actually have an error code 43. This camera is absolutely rubbish. Should have stuck with my old webcam. But I can always use both of them at once. So this one is telling me about the code 43. So this is exactly what the customer said was the problem with the graphics card. I don't suppose loading the drivers will help. I don't have any Radeon drivers on this hard drive as far as I know at the moment, so I will try and load them anyway, but I don't expect that will resolve the problem. Well, it seems to think the graphics card is there, so it's actually detected it, I believe. So let's see if this actually does install or not. So I installed the drivers, I thought, restarted. I still have the error code 43. This is the GPU-Z, because I'm English, yeah, and it knows the card's there. It's telling me that the GPU and the RAM have a 0 MHz clock, which doesn't look very useful to me. Because the owner mentioned something about overclocking or before overclocking, I think the first thing I will actually do with this is to reprogram the BIOS. And because I like to do things the hard way, according to a lot of subscribers, I'm actually remove the chip, stick it in my EEPROM programmer, make sure there's a good file in there, and then let's see if it makes any difference. Okay guys, so I downloaded the BIOS file from Tech PowerUp for this graphics card. I reprogrammed the BIOS by actually removing the chip, put it into my EEPROM program, do it the hard way. I've done this a number of times on video, so I will actually link a video here showing you how to do that if you want to do that. And when I reprogrammed the BIOS, I put it back in and found it was doing exactly the same thing. So it loads Windows, we have an error 43. I can install the drivers. I tried it again. It does detect the card during the installation, but it doesn't change the resolution, and at the end when it has to restart it comes back up and it's still not working. So once again in Windows we have an error code 43. So after that I actually ran a memory test using a Linux, sorry I get told off for saying that, using a Linux script, and the memory test actually tells me I have a problem. So this Linux script called DMGG, I made an 18-minute video, short for me, explaining how to create a bootable USB stick with a script and how to use this to test these memory cards. And this script will actually show you which, if any, memory chips are faulty. So I can just show you now the results I have from that. Okay, so you can see it on the screen here. This is the actual script running there, Python 3 dmgg.py. E, all the zeros is the address of the card, 10 megabytes, and 8 is the number of chips. How to do this, I will link the video straight at the end of this one so you can go and watch it. So this is actually running the test, and it's telling us here that we have faulty. So we have chips 7 and 8 are faulty. It's saying number of faulty chips 1, but it doesn't know which one. Sometimes you find that. So we definitely have faulty memory on this card, and that's why we have this problem. So now I need to have a look to see if I can get some memory, and I will inform the owner, and then he can decide whether to pay for the replacement memory and have it fitted, or whether just to have the card sent back, or whatever he wants to do with it. Okay, so that is the cause of the error 43. Almost certainly we can't say any more until we've replaced that memory. So let's have a look to see what we need and how much it's going to cost. To figure out which chip is which with this software is quite simple. So you start from pin 1 on the chip. You can see here it's like a little arrow on it on the GPU chip, and you come to the opposite corner, and then you go round anti-clockwise. So 1, 2, 3, 4, 5, 6, 7 and 8. So these are the ones where it says the problem is it's one or both of these. The memory type is actually marked on it. It's Micron memory, and it's marked D9VVR. Yes, I know I did put too much heatsink compound on. I said I think this is too much, but no worries. After we've replaced the memory, if that's what the customer wants to do, then I can clean that up. So don't need to chastise me that much for that one. Yeah, it happens sometimes, but we can fix it. So let's have a look to see how much this is going to cost to repair. This is the actual memory on AliExpress. So you can see here we have a number of different options, and one of them is D9VVR, so that's the one we want. The price for each chip at the moment on special offer is €8.48, otherwise it's €9.98. So it's less than €10 per chip with a little bit of postage. So we can just put quantity of 2. Yeah, the postage went up. That surprises me because the postage actually more than doubles, which makes you think you might as well just order 2 separate ones, and they'll probably put in the same package anyway. It'll cost you less money, yeah. So don't let that fool you, okay? Just order 2 separate orders. So we have 144 and let's say 848. Even assuming the customer doesn't get back to me quick enough before this offer ends, it's still like €11.50 for each one, so €23. If he's a little bit quick, he might save himself €3 off that. 20, 23, I don't think it's going to make much difference whether the guy wants it fixing or not at that price, okay? So I'll let him know. In fact, he's no doubt going to be watching this video, and then we can decide. But that's basically the cost of repairing this. To change the memory chips, this is actually not that difficult to do. I've done this on previous videos. I'm sure I can find one and link it to this one. But basically, you can do this with just a little preheater underneath. I use a Carlos 853B, sorry, a little hot air preheater to warm the card from behind. I would take this metal bracket off first just to help the heat conduction into it. Get a preheater under there, get the whole board up to about 120 centigrade, and then you can come up with your hot air station here, and you can literally remove it. I would suggest you put a bit of Kapton tape around the capacitors nearby. And that's really all you need to do to change the RAM. So it's not a job that requires a lot of specialist equipment, but it is a job that requires quite a bit of practice to do it without ripping any pads off the board. So if you're going to be doing this sort of work, really you need to initially get some scrap graphics cards. Even old ones have these type of chips on them, or anything else. Maybe some laptop motherboards might have memory on board, and just practice on a few scrap boards. Once you can do it on a scrap board every time without damaging the board, then you can just come onto these graphics cards. You don't need a lot of kit, you just need a bit of experience to do it. Okay guys, so I hope you enjoyed that one anyway. It wasn't a difficult diagnosis to make. Anybody can make this diagnosis. You probably noticed, guys, you could have just tested that using the software. You don't even need to take the graphics card apart to do it. So anybody at home, if you're watching this, guys, get onto the following video. I'm linking right at the end of this one. Make yourself a USB stick and you can test these things without even taking them apart. Hope to see you all soon on another Learning Electronics Repair video. And one thing left to say, ciao for now, guys.